This is Pythagorean Theorem Reteach. So the first question is just asking us to label this right triangle. So it doesn't matter where A or B go. I'm just going to put A, oops. I'm just going to put, let's see, A here and B here, but it could be backwards because the legs, which goes here, doesn't matter which side of the right angle they're on. C matters, that has to be here, and that is the hypotenuse. Okay. Number 6 is a right triangle, and you see the squares on the sides, and they want to know which equation represents a relationship. Well, first thing you're going to do is label your triangle A, B, and C. A, B, C. Remember, C is directly across from the right angle. And then we look at our answer choices, and it's going to be the one that goes with Pythagorean theorem, because that's the model for Pythagorean theorem. You have squares on the sides of the right triangle. So we substitute in, and we get this one, which is the same thing as B. Okay, number 7, what is the length of one side of the largest square? So if we look at this, this is our largest square. And I notice I can't count this because it's the diagonal. It is the hypotenuse of that right triangle. These I can count though, because they're just, straight. So when I count the spaces, I get 1, 2, 3, 4, 5, 6, 7, 8. I think there's 9. Let's see. 1, 2, 3, 4, 6, 7, 8, 9. Yes, 9 on that side. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on that side. So I have to use the Pythagorean theorem to figure out how long this side is here. I have to find C. I know it has to be the longest side, so I know it can't be A and it can't be C. So at least I know it has to be B or D. So I'm going to substitute in A, B, C. 9 squared plus 12 squared equals C squared. So 81 plus 144 equals C squared. 225 equals C squared. And remember, to find C, I need to take the square root of 225, and that gives me 15. So B is our answer. Number 8, is the following a model a representation of Pythagorean theorem? I know that we see a right triangle and it's marked, but that doesn't make it a model. This question is not asking, is this a right triangle? They're saying, is this a model? So for a model, we talked about needing A, B, and C to be in the right spot, but there's no A, B, and C on here, so that's not what we're talking about. The other thing we talked about is these figures here have to be squares. Are these squares? No. We have rectangles instead of squares. So you needed to say something about that in your answer. Okay, number 9, an artist joined 3 square regions, so that's important, they are square, at the vertices to create the figure shown in the diagram. What figure? I see that this figure is a right triangle, so right away I am thinking about Pythagorean theorem. Okay, the artist will use small congruent square tiles to cover each region without any gaps or overlaps. So based on the information, which statement is true? So that reminds me, the small congruent square tiles are like those little post-its we saw in the Pythagorean theorem in 2 minutes, where they played the music and all the post-its came in, and you saw that the area of the 2 smaller squares equaled the area of the larger square. So let's see, the number of tiles needed to cover region X is the same as the number of tiles needed to cover both Y and Z. So this one is saying X equals Y plus Z. So when I look at that, that's the smaller one equals the big one and the medium one. That's not right. Okay, the number of tiles needed to cover Y is the same as, so Y equals x plus z. So that's saying that this one is the same as x plus z. The medium one is the same as the small plus the large. That's not right either. So it cannot be C. Oops, I skipped one. I meant B. All right, let's look at C. The number of tiles needed to cover region Z is the same as x plus y. So let's go look at our picture. So they're saying the big one is equal to the two smaller ones. Well, that's exactly what the theorem says. The two smaller squares have to equal the largest square. So C is the correct answer. Okay, number 10. Now the rest of these 10 through 15 is really using the theorem to either solve problems or the converse of it to tell whether or not we have a right triangle. So a 24-foot ladder is leaned against a 20-foot wall, and we see in our picture we have 24 feet and 20. How far from the base of the wall should the ladder be placed to reach the top? And you have that question mark there. So you need to realize that there is a triangle here. Okay, so I'm going to draw it over here so I can draw it bigger so I can see what's going on. First thing I'm going to do with any triangle, right triangle I draw, is label A, B, and C. And then I'll put my numbers on. This is 24, so that's my hypotenuse. This is 20, that's A, according to my picture. It could be B. And then this is the one I'm not sure what it is. So I'm going to write down my theorem. A squared plus B squared equals C squared. Then I'm going to substitute in my values from my picture. My A was 20, so 20 squared plus, we don't know what B is, that's what we're looking for, so B squared equals 24 squared. Okay, so 20 squared is 400 plus B squared is 576. Now, since I need to figure out what B squared is, and 400 plus B squared equals 576, I'm going to subtract 400 from both sides because I have to get that B squared by itself, just like when we solved equations towards the beginning of the year. So B squared equals 176, but I'm not done because I need to know what B is, so I need to take the square root of 176. And that is about, because it's irrational, let's see, 13.26, and then it does go on, which makes H our answer because we are rounding to the nearest tenth. Okay, so we should have looked at our answer choices first. So let me go back and just check like my reasonableness of this answer. I know my hypotenuse is 24. So I know that this question mark has to be less than 24. So I can get rid of these two right away. So then it just would be the two you have to go between if you forget how to do the theorem. Okay, number 11. What is the distance between the 2 points on the coordinate plane? So the 2 points are there. I'm going to go ahead and connect them with a line segment. And as soon as I do that, to me, I see a right triangle. That's a hypotenuse of a right triangle. So I'm going to go and draw my right triangle in. And then I'm going to count my units along the bottom, the base of the right triangle. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to count my units on the height of the triangle. 1, 2, 3, 4, 5, 6. And I'm looking for this side over here. So my right triangle, my right angle's here on my right triangle. I'm going to draw an arrow, and then I'm going to see the hypotenuse. And then I just put A and B wherever. I usually go bottom and side. Okay, so I'm going to write down my theorem. A squared plus B squared equals C squared. Oh, let me look up my answer choices. I know C has to be the longest side, which means it can't be 6 and it can't be 8 because those would be equal to one of the sides and not the longest. So it's either C or D. So A, I have A is 8, so I'm going to do 8 squared. B is 6, 6 squared equals c squared. I'm trying to find that out. So 64 plus 36 equals c squared. 100 is c squared. So c is the square root of 100. So c is 10. Okay, number 12, a scale drawing of the floor of a rectangular bedroom is shown. What are the dimensions? And I remind you, that's the length and the width of the room. So the length and the width, we're talking about this, the length, this is what I would call the length, and this, which is the width. When I do that, I see, oh, I have a right triangle here. Okay, so what I'm really asking is, what is this length right here? So let me draw my triangle. Well, no, I guess I don't need to draw it. Hang on. I can write in here. What I want to do is label it. So again, I have my right angle. I draw my arrow. I see the hypotenuse. And I put down A and B. Okay, so I'm going to use my theorem. Let me write down my theorem. Ooh, that's a C. Let me fix that. So, hang on. A, well, I don't have a number for A. So I don't have a number for A, so we're just going to leave that A squared. B is 3, so 3 squared. And C is 5, so 5 squared. So 3 squared is 9. 5 squared is 25. Again, they're on opposite sides of the equal sign. So I'm going to subtract 9 from both sides because I'm trying to get that A squared by itself. That's 16. So A is the square root of 16, which is 4. So that makes that side 4. So when we're talking about dimensions, the length and width, a lot of times they'll measure those rooms like a 5 by 8 or like even a picture, like a 4 by 6 picture. So that's what this by inches, 3 inches by 4 inches. So it is J. Okay, 13. Billy's building a bicycle ramp. What is the total length of the ramp? X plus Y. So Billy is going up the ramp that way, and then he's coming back down the ramp this way. So we have to figure out what the blue is. So if we look, you have a right triangle here, and we have another right triangle here. So we really have 2 problems to solve. So I see that if I draw my arrow from this right angle, this is C, that's a hypotenuse of that triangle. And the same thing goes over here. If I draw from the right angle, I see my hypotenuse there. So I'm going to do X first. So I have A squared plus B squared equals C squared. And I'm just going to do A and B. And so then over here, I'll call that A. And so B is still 8. So A is 15. And B is 8. And that is X squared. Since we use an X, that's what we're trying to find. So 225 plus 64 equals X squared. So I have 289 equals X squared. So X is the square root of 289. And that is 17. Okay, so that means that Billy is going to be, oops, oh my goodness. There we go. Billy is going to be traveling up the ramp 17 feet. Okay, so I just realized your test, the 6 and the 15 are flipped around, but I fixed it so it would look a little more realistic for next year. So it doesn't matter what side your 17 is on. You're still going to do the same problems. Okay, so now this time on the other side, coming down the ramp on this test, which would be the other side for y'all's test, we're doing again A squared plus B squared equals C squared. So A is 6. and b is 8. And now I'm going to find y. So 36 plus 64 is y squared. 100 is y squared. Y is the square root of 100. So y is 10. So he's coming down the ramp 10 feet. So to go up the ramp and then down the ramp, x plus y is what it says in the problem to do. 17 plus 10 is 27 feet. So H. Okay, 14. Which squares will not form right triangles when joined at their vertices? So not. So we're looking for the ones that are false or that don't work or that we say no for. So I look at my squares. They all have side lengths. So remembering Pythagorean theorem says the two small squares, the area of the two small squares have to add up to the area of the large square. So I'm going to go through and find these areas. So 12 squared, the area of that square is 144. 7 squared, 49. And 3 squared is 9. So 49 plus 9 is 58, not 144. So this one's false. You could also put that in your calculator. I saw a lot of kids do that. They did 3 squared plus 7 squared equals 12 squared. Hit enter, their calculator said false. As long as you're working with integer side lengths, you can use your calculator to do that. So if you forgot how to do the theorem on your, not your EOC, on your STAR test, you could go back, use all your answer choices. The problem is if your answer choices are in decimals, that's not going to work. You're going to get false statements all the way down because those decimals are rounded. So keep that in mind. All right, so number 2. We use red. That's an 18, and 18 squared is 324. And that's a 10. 10 squared is 100. And 8 squared is 64. So 100 plus 64 is definitely not equal to 324. So this one's also false. Okay. All right, number 3, let's use green. 12 squared is 144. 9 squared is 81. 6 squared is 36. And 81 plus 36 is 117. So this one's also false. Okay, and then number 4, 17 squared is 289. 15 squared is 225, and that's an 8 squared is 64. 225 plus 64 is 289, so this one's true. So be careful when you're doing your answers. Remember, we said we're looking for the one that's not true. So I need the answer choice that has 1, 2, and 3 in it. So G. Careful you don't go ahead and say J, since that's the only one that is true. You have to read your question. And number 15, which measures could be the side lengths of a right triangle? Well, if a squared, I'll write it down here, if a squared plus b squared equals c squared, then we have a right triangle. So the only thing I have to be careful about is to figure out where c is. Remember, that's the longest or the biggest number. So 7, 21, 25, this one is c. So let me see how that works. So 7 squared plus 21 squared equals 25 squared. If it does, then we have a right triangle. So 49 plus 441, does that equal 625? Not even close. All right. So, and again, you could do these on your calculator, 490. You could put this right here, this in your calculator. If it says true, you have a right triangle. If it says false, you do not have a right triangle. Okay, so this one was false, so not A. All right, let's look at B. Let's see, 78 and 72. So, oh, see, look, C's right there in the middle this time. It's a little tricky. So 30 squared plus 72 squared, does that equal 78 squared? I'm going to need to get my calculator here. So 30 squared is 900 plus 72 squared, give me a moment till I do that one, 5,184. Does that equal 78 squared, which is 6,084. Okay, so 900 plus 5,184 is 6,084. This is true. 6,084. So that one is a right triangle. Okay, we should check the other ones though, just to make sure, just in case we made a mistake, but I'm kind of out of room here, so I'm going to erase this problem here quickly and see. I'm going to try C and D just to make sure. And you know, if you have a calculator, that really doesn't take much time at all, and it would be good to, you know, make sure you have the right answer. All right, here we go. Let's do green. So 3, 9, and 5. 9 is your longest side. It's in the middle again. All right, so 3 squared plus 5 squared, does that equal 9 squared? So 9 plus 25, does that equal 81? No, it doesn't. 9 plus 25 is 34. 34 does not equal 81, so that's false, so it's not that one. Okay, and blue, 7, 25, and 26. There's C, the longest side. So 7 squared plus 25 squared, does that equal 26 squared? 49 plus 625, does that equal 76 squared is 676. Well, if I add 49 here, I'm going to get, what, 14, 674. Oh, very close, but not equal, so not the right answer. Okay, so make sure you've written out your test corrections, saying what you did wrong or why the answer is now right. Don't forget to do your extra practice and then take the retest on whichever TEK you need.